Dear students, in this session we learn about constructor, destructor, different types of constructors and timing of constructor in a C++ program. Initialization of objects. How to initialize an object. In variable declaration of ordinary programs, we can initialize the variables using equal to sign or assignment statement. Initialization of object is little bit different from ordinary variables. In the case of a variable, a compiler allocates memory during definition, but it does not assign any initial value. And C++ automatically initializes only for static and global variables. If we are defining static and global variables in C++, that will be automatically assigned or initialized as 0 during its declaration. All other variables are not initialized by default. We should give initial values to such variables. Member functions can be used to initialize member variables of an object. Whenever we want to initialize with an object with some value, we are usually defining a function and we are calling that function with the name of object as shown in the example ob1.getData. In the getData function, we are usually writing the statements for assigning values into ob1. Initialization of objects can be done automatically by using a constructor. This is the another method of initialization of object variables, that is by using constructors. So what is a constructor? Constructors are special class member functions which are called by the compiler every time an object is created. So this is a function, it is a member function as any other member function, but these are some special functions which is automatically called by the compiler. We, the programmer, do not need to call it separately. It will be automatically called by the compiler. That is the speciality of a constructor function. Then the constructors have the same name of the class and may be defined inside or outside the class definition. That is the another speciality of a constructor. The name of a constructor is same as that of the class name. So we can define a constructor only with the name of that class. We can also define the constructor outside the class as any other member function using scope resolution operator. It must be defined as public. That is another condition for defining defining constructors. And also it has no return values. We cannot define any return type with the constructor function heading. That means we cannot return any value. So we have three types of constructors. One is default constructor, the second one is parameterized constructor, and the third is copy constructor. These are the three different types of constructors we are using in C++. So default constructor. A constructor without any arguments or with a default value for every argument is said to be a default constructor. A constructor without any argument. If a constructor does not have any argument, it will be treated as a default constructor. And similarly, if the constructor have a default value for every argument, then also it is said to be a default constructor. We can see some examples. It will be more clear from the examples. Default constructors are called when no other constructors are defined. Default constructors are called when no other constructors are defined. We can define many constructors in a class. If we have not defined any other constructor, default constructor will be called automatically. This is the syntax of a default constructor. It is defined under public. The class name, because the name of the constructor is exactly similar to that of the class. Then code of the constructor, body of the function, constructor function within curly brackets. This is an example for default constructor. Class test public int id. This is the only member variable of this class, which is defined as public. Then test is the constructor without any parameter. It is a default constructor, test. Here test is the name of the class. Then inside the constructor we have written a statement cout default constructor called, then id equal to 0. id is the member variable of this class and that id is initialized to 0 inside the constructor. Then end of the default constructor and then end of the class. Now coming to the main program, the first statement is test obj1. Here this is the declaration of an object with the name obj1 using the class test. This time the default constructor will be called automatically. We are not explicitly calling the constructor, but the constructor is called at this moment and the statements inside the constructor are executed. id gets a value 0, id gets a value 0 as shown here. Then we are printing that id value cout obj1.id, then inline. Here we can we can refer this id directly in the main program only because the id is defined as public. Otherwise we cannot print like this. id is defined as public in the class. Next one is parameterized constructor. A constructor with any arguments is said to be parameterized constructor. A constructor with any arguments. If you are writing a constructor with any number of arguments, it is called a parameterized constructor. This is also used to initialize the values when an object is created. The syntax is little different than the previous one. Class name parameter list. We have already studied about function with the parameters. The syntax of this constructor is exactly similar to that kind of functions with the parameters. Class name parameter list, within curly brackets the body of the constructor. Here is an example for parameterized constructor. Class test public int id, then test within brackets int x. Cout default constructor is called, that is just for printing during the runtime, which shows it is called the parameterized constructor automatically, that's all. Then inline id equal to x. See, this statement assigns the parameter value x into the member variable id. So we can send a value from the main program to this parameter x, and that x will be used to initialize the value of this member variable id. Then end of the parameterized constructor, then end of the class. So coming to the main program, test obj1 within brackets 10. Here 10 is the parameter. This parameter is passed into this constructor test, and the 10 will be received by the variable x. Then that 10 in the x will be assigned to member variable id. So here we are printing that id value cout id is obj1.id. So we will get a result 10 because this 10 is assigned to member variable of obj1 through a parameterized constructor. This is a demonstration program for parameterized constructor. The next one is copy constructor. A copy constructor is a member function which initializes an object using another object. Using another object of the same class. So actually we are copying the values of one object into another object using a constructor. That's why it is called a copy constructor. A copy constructor has the following general function prototype. Class name, the constructor name, class name are same. Within brackets, again class name, then a reference variable of an existing object. Here an address of an existing object is received as the parameter. Class name is the constructor name. Again, class name is the data type of this existing object. It is a reference variable, that's why we are putting an ampersand in front of it. Here is an example. This is a class point. Here the variables are private x and y. Then a parameterized constructor int x1 into y1. Inside the parameter constructor, we have already studied this parameterized constructor. We have two parameters in the parameterized constructor point. x1 and y1 are the parameters. x1 is assigned to variable x, y1 is assigned to variable y. We have two member variables x and y. So x will be assigned with x1, y will be assigned with y1. This is the duty of this parameterized constructor. The next one is copy constructor. We are writing one more constructor with a different kind of argument. So this is valid. We can define more than one constructor inside a class. The only one condition is the parameters must be different. Here int x1 into y1. Here the parameter is point ampersand temp because it is a copy constructor. So temp is the pointer variable to an object of data type point. The point is the name of this class name. So this object is the same type of this point, and the constructor is also point. Here listen to the statement x equal to temp.x. Since it is a reference variable, its x value can be retrieved by using dot operator temp.x. This temp.x is assigned to x. Temp.y is assigned to y. So an object is coming as the parameter. That object's member variable values are assigned to another object of this function call. Whenever we are creating an object, that object's member variable gets values from another object. Then it is int get x to return x, int get y, return y. These two functions are required here because x and y are private variables. This x and y cannot be accessed in the main program directly. So we are using another member functions to get the value of x and y in main program. Then end of the class. And here is the main program. First is point p1 10, 15. In this case we have two parameters. So parameterized constructor will be called from here. We have two constructors in the program. One is parameterized and one is copy constructor. So compiler automatically detects which constructor is to be called by examining its parameters. Here we have two parameters, so the parameterized constructor will be called. The second is point p2. This is for creating another object p2 equal to p1. Listen to the statement p2 equal to p1. Here p1 is the existing object. Here p1 gets the value 10 and 15 into x and y. So p1 is an existing object. Now copy constructor is called here. The p1 is passed into the reference variable of the copy constructor. So here temp gets the address of p1. So this becomes p1.x, this becomes p1.y, and p1.x will be assigned to x, p1.y is assigned to y. So these x and y are belongs to p2 because we are calling this constructor for initializing the object p2. So x and y of p2 gets the values from x and y of p1. Similarly, the next is another type of constructor invocation, point p3 within brackets p1. Both these statements are same. We can use equal to, or we can use the existing object as a parameter. Both will invoke the copy constructor of the class. So to access the values of these objects, we can write the statements like this: cout p1.x. p1.x can be printed by using p1.getx. So getx function returns the x value of p1 and that will be printed. Similarly, getY returns the y value of p1 and that is printed on the screen. Similarly, p2getx gets the value of p2. p2.getY gives the value y value of p2, and p3 gets the x value of p3. p3.getY gives the y value of p3. All these values will be printed in the main program, and finally a return statement 0. Now you can experiment this program and you can examine what you are getting as the output. From this output you can understand the execution of these constructors. The next one is a conversion constructor. It converts a constant value into an object. In C and C++, many kind of conversion methods are possible. An integer can be converted into float. A float can be converted into double. And any small value can be converted into large data type with some limitations and rules. A float can be converted into integer. Here also some limitations are there. So different conversions are allowed in C and C++. Then typecasting operator can be used to convert from one type to another type. Here it converts a constant value into an object. That's why it is called a conversion constructor. A constructor can be used to store a constant value into an object. Actually, it is a parameterized constructor with a single argument. Then which value we have to copy into an object, or which value we have to convert into an object, is to be transferred to the function parameterized constructor. Copy constructor can act as a conversion constructor. So copy constructor with one parameter can act as a conversion constructor. Then class name data type variable. It's a simple syntax. Only one parameter is there. This is an example. The class test, private variable x, public variable test int I. This is a parameterized constructor. I is a parameter and that I will be initialized to variable x. Then there is a show function to print the value of x. End of the class. See the main program. Test T20. So an object T will be created by using the parameterized constructor called T.show. We can print the value of T. That is 20 will be printed because this 20 is assigned to variable x. So T.show prints, coming to the show function, t dot show prints the value of x. You can see this here, see out x. So this x will be printed. So 20 will be printed during the first t dot show. Then see the next statement, t equal to 30. Here the L value is a t, that is an object variable, but R value is an integer value, integer constant 30. So an integer constant is assigned to an object, t equal to 30. This is a conversion from integer to object. Actually, this time the parameterized constructor or the conversion constructor is called, and 30 will be copied into the parameter. That parameter will be assigned to the private variable of t, and t dot shows 30. So different type of function calls are explained here. T20, t equal to 30. Both calls the parameterized constructor of this class. The second call can be treated as a conversion constructor or conversion of one data type to another data type. Then coming to the destructor. This is just opposite to the constructor. Destructor is a member function which destructs or deletes an object. When constructor creates an object, destructor destroys an object. A destructor function is called automatically when the object goes out of scope. Destructor is also executed automatically. The constructor is also doing like that when the object goes out of scope. When the object goes out of scope, there are three conditions to get the object out of scope. One is when the function ends. When a function ends, all the objects defined inside that function goes out of scope. When the program ends, that means every objects created inside a program are going to out of scope at the end of the program. The third case is a block containing local variable ends. If an object is defined as a local variable into a block means a set of statements enclosed between curly brackets. So a block containing local variables ends. So any object defined inside a block of statements will be going to out of scope when that block terminates, when seeing the closing bracket of that block. These are the three cases of an object goes out of scope. So at that moment the destructor will be called automatically and it destroys the memory allocated for that objects. So how can you identify a destructor? A destructor have same name as the class preceded by a tilde. Tilde symbol is shown here. It is available in the computer keyboard. Destructors have the same name as that of the class. So constructor also have the same name of the class. Destructor has the same name, but to distinguish between constructor and destructor, we must put a tilde symbol in front of it. Destructors have the same name of the constructor, but it is starting with a tilde sign. It don't take any argument. Destructors don't take any argument and don't return anything. It cannot receive any argument or it cannot return any value. Only one destructor in a class is permitted. Only one destructor in a class is permitted. In the case of constructor, we can write more than one constructors in a class with different kinds of parameters. But here there is no parameters and therefore we cannot define more than one destructor in this class, in a class. Destructor is called only if object is constructed. there is another criteria, another condition for the destructor. A destructor is called only if object is constructed. If we are not constructed an object, its destructor will never called automatically. Then why we are using destructors? When a class contains a pointer to a memory allocated in class, we should write a destructor to release the memory. So usually we are allocating memory when defining objects. These memory spaces must be freed before the class instance is destroyed. Class instance means object. Before the object is destroyed, we must release all the allocated memory for objects. Otherwise, the system leads to a memory leak. Memory leak means the garbage collection in memory. So, wastage of memory can be reduced by using destructors. When a destructor is called, that memory is deallocated. So, especially for small memory capacity machines, we must define a destructor. This is a kind of programming ethics. In all other cases, we do not need to write our own destructor in class. Compiler creates a default constructor for us. So, for ordinary classes, that is, if we are not using a pointer or if we are not using dynamic memory allocation in a class, such objects will be destroyed automatically by the compiler. But if we are assigning any memory location using a pointer or using a dynamic memory allocations, that memory area should be freed by writing destructor in that class. Otherwise, a destructor can be avoided. This is a simple example for destructor. See, class hello world. The constructor is there. Constructor is called destructor, starting with a tilde symbol. The name is same as that of the constructor. Destructor is called void display hello world, then end of the class. This is just a simple demonstration program to understand when a destructor and a constructors are called. When the destructor is called, a message will be printed. When a constructor is called, another message is printed. See the main program. Hello world obj. We are creating an object with a hello world class. So hello world class object will be created through constructor. So the constructor will be called and constructor is called, message is printed. obj.display. So this display function will be executed. We will get another message, hello world. Next, return 0, end of the main. So this object goes out of scope when reaches this closing bracket, because this obj is defined within this block of statements of the main program. So at this moment, just before the closing bracket, destructor is called automatically. So we will get another message, destructor is called. That's all. This is a simple demonstration program. This is another program for destructor. See, class A global variable is defined here. This is the destructor, I equal to 10, then bracket closed, then class closed. This is a user defined function f1. Here we are assigning a value 3 to I, a ob, that means using this class A we are creating an object, then return I, then destructor is called here because this ob is destructed when we are reaching this closing bracket. In the main, cout f1 That's all. A function call is happening here. The function calls, during the function call, I gets a value 3 and object is created, then return I, then return 0. So this is another demonstration program for Destructor, and after execution of this program you can find out when the Destructor is called, how many times the Destructor is called, everything you can understand. So when a Destructor is called here, I value gets 10. Since it is a global variable, I value changes. So Destructor called here. So when Destructor is called, I value will be changed to 10. So whether you get I value 10 or you get I value 3, that can be examined by using this program, and you can identify how Destructor is called when the object goes out of scope. Next is timing of constructor and destructor invocation. From the previous program itself, you can identify the timing of a constructor and a destructor invocation. The previous program for destructor invocation. The constructor is called after the object is constructed, and the destructor is called before the object is destroyed. So usually constructor is called after the object definition and destructor before the object is destroyed. The actual time of constructor destructor invocation depends on the scope and storage class of the object instance. You already studied about the scope and storage class of the object instances. Scope defines the accessibility of variables and objects for different parts of the program code. You have already studied the scope. I am again mentioning the definition of scope. That's all. Similarly, storage class defines the lifetime of variable and objects from their creation to their destructions. So storage class defines the lifetime. Scope defines the accessibility of data items. So constructor invocation timing. For global objects, constructor is called before main. Constructor is called before main. Before the execution of the main program, global constructors are executed. We can define objects globally. In that case, constructors are executed before the main program. Then non-static local object. Constructor is called when the execution reaches point where the object is declared. So constructor is invoked when the object declaration is found. This is usually we are doing in every programs. Non-static local object. This is the ordinary object declaration method. Then static local object. We can define static objects also. In that case, constructor is called only once, first time execution. Every static variables gets the value only once. Similarly, a static object gets the value only once during the first time execution. The all other object creations, this constructor will not be executed. Then class scope. When an object is created, compiler makes sure that constructors for all of its sub-objects are called. This is in the case of inheritance, and if we are defining a parent class and a child class, the object is created with a parent class, and the compiler makes sure that the constructors for all of its sub-objects. So the constructor will be executed for the base class and derived classes. Timing of destructor invocation. A destructor is automatically called when the program finished execution. When the scope of a local variable ends, and when you call the delete operator for a dynamically allocated object. These are the three cases where destructors are called automatically. The one is the program finished execution, the usual end of the program. When the scope of a local variable ends. When the scope of a local variable ends means when we are defining a local objects, when its scope is finished at the end of that local block. So at that time the constructor is invoked. When you call the delete operator for a dynamically allocated object. As you know, the delete operator is used to delete dynamically allocated objects. So whenever we are deleting, the destructor is invoked. These are the three cases for destructor invocation. So constructor invocation is always doing just after the definition, and destructor invocation happens just before the end of the block. So these are the topics we have discussed in this video. Constructors, how to define a constructor, how to define various kinds of constructors, how to define a destructor, and how these constructors and instructors are invoked.